Today on Capechi's Corner, we're going to look at inequalities for one triangle. Before we look at our first theorem, let's take a look at the triangles we have. So this first triangle, we have an isosceles triangle because both of the sides have a length of 10. And because of that, we know the angles opposite those sides are congruent. So because AB is equal to BC, we can say that angle A is also equal to angle C because they're congruent. Now look what happens when we take that side BC, and it was originally 10 and we extend it. So what happens when we extend BC and we make it longer, angle A also becomes larger as well. So we can say that segment BC is now greater than segment AB, and because of that, we all now know that measure of angle A, which is across from segment BC, is greater than measure of angle C. So our first theorem today says if one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. And this is only going to work if these sides and these angles are in one triangle. So when we're looking at a diagram and we want to know which angle is the largest, we have to compare the sides. So let's look at example 1. So in number 1, we have a side as y. We also have a side as y plus 2. And we have another side as y minus 2. So the largest side is actually going to be y plus 2 because no matter what value y is, let's say it's 6. If we give y 6, then y plus 2 would be 8 and y minus 2 would be 4. So because of that, this side right here would be the longest side. So therefore, the angle across from that, angle 1, is going to be the largest angle. In number 2, we only have measurements on that triangle on the right. So let's see what we can do with that. We have markings, so it looks like I have parallel lines. Opposite sides are both parallel, so that would make that a parallelogram. And we also know that opposite sides of a parallelogram are congruent. So because of that, we know that this is 24 here, so this side's also 24, and this is 21, that makes that 21. Now the largest side on both of these triangles are 24, so the angle across from it is going to be angle 1. So in this case, angle 1 is also the largest angle. Let's take a look at our next theorem. But before we do that, again, we're going to look at some triangles. So our top triangle, again, we also have an isosceles triangle because the measure of angle y is equal to the measure of angle z. They're both 70. So therefore I have an isosceles triangle, and because of that I know that segment xy is also going to be congruent and equal to segment xz. So look what happens in that second diagram. As I make the measure of angle y larger as that increases, then this side xz also increases. So our theorem states if one angle of a triangle is larger than a second angle, then the side opposite the first angle is longer than the side opposite the second angle. We are now asked which segment is the longest in our given diagram. So let's look at number 1. Now we know the sum of the angles of a triangle are equal to 180. So let's see what we have here. We have 60 plus x plus 1 plus x plus 3 is equal to 180. So that gives me 2x plus 64 is equal to 180. Isolate my variable, I have 2x is equal to 116, so x is equal to 58. So let's find the measures of the other angle. So if this is x plus 1, then this measure of this angle is 59, and x plus 3 would give me 61. So my three measures of the angles are 60, 59, and 61. So since 61 is my largest angle, my side across from it, segment DF, is going to be my longest side. Let's look at number 2. Number 2 is a great problem. We have to look at these triangles individually. So let's start with the bottom triangle, triangle GIH. And in this triangle, I know I have a 90 degrees, I have 15. If that's 15, then I know this has to be 75. So my longest piece right here is going to have to be GH of that triangle GIH. Now let's look at the triangle above it. And in triangle GJI, again, the longest segment is going to have to be the one across from that 90 degrees, that hypotenuse. So that's going to be my longest side in that triangle. However, when we compare it to the bottom triangle, this red line, segment GH, is still going to be the longest because it's across from the 90-degree angle there. Let's keep going up. Let's take a look at the next triangle. When I look at the triangle JKG, again, I have a 90 degrees, so my longest side is going to be my hypotenuse. But again, if I then go look at my middle triangle, the green line is still longer than the blue line. And again, if I look at that bottom line, my red line is still going to be longer than my green line. So in the end, my longest segment is going to be segment GH. Let's take a look at our last theorem for today. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So in looking at example A, my lengths are 4, 4, and 7. Now, to test this theorem or to make sure that it's working, I always take my two smaller sides. So I have 4 and 4. Since 4 plus 4 is greater than 7, since 8 is greater than 7, I can form a triangle with these measurements. But in example B, my sides are 3, 3, and 7. And 3 plus 3 is not greater than 7. That's 6. 6 is not greater than 7. So that's why 6 is less than 7. I cannot form a triangle with these measurements. So we have the question, is it possible for a triangle to have the given lengths? So let's look at number 1. Our sides measurements are 3, 4, and 5. So if we take our two smaller sides, 3 and 4, 3 plus 4 is greater than 5, so that's okay. That answer is a yes. We can make a triangle with those given lengths. Now look at number 2. 1 plus 1 is 2. 2 is not greater than 4. That doesn't work. So I cannot form a triangle with those given measurements. Two of the sides will just not be long enough. I can't make them match. Now in number 3, I have 2 plus 4, and then I have 6. Well, if I can compare 6 and 6, they're equal. But that's not what the theorem says. The theorem says that the sum of the two sides have to be greater than the third side. So that answer is also a no. I cannot make a triangle with the given lengths. Let's take a look at our directions for the last examples for today. It says the lengths of two sides of a triangle are given. Complete the statement. The length of the third side must be greater than blank, but less than blank. So let's look at number 1. I have 5 and 15. So one thing I'm going to do is I'm going to add these values, and when I add them, I get 20. And the other thing I'm going to do is I'm going to subtract them, and when I subtract them, I get 10. So let's see what this means. If I take my lower value, I know that my missing segment has to be greater than 10. And how do I know that? Well, if I take 5 plus 10, that's going to give me 15. And I know I can't have it equal. It has to be bigger than that. So that's why it says greater than 10. I can have 10.1 would work, as 10.1 plus 5 gives me 15.1. Any value greater than 10 will work. The other thing I have to do is at the same time, though, it has to be less than 20, my other value. Now remember, when I add up the two sides, they have to be greater than the third side. So 5 plus 15 will give me 20. So I need to make sure that that value, that third side, has to be less than 20 because 5 plus 15 is equal to 20, so that's not going to work. If I have a value that's greater than 20, like 21, 5 plus 15 is only 20, so that's not going to work either because the sum of those two sides are not going to be greater than that third side. So in the end, because of the segments that I'm given, the third side has to be greater than 10 but less than 20. Let's do the same thing for number 2. When I subtract these values, I get 6, and when I add these values, I get 34. So I know that my measurement of my third side has to be greater than 6, but at the same time has to be less than 34 in order to form a triangle with the 3 given sides. We're going to do the same thing with number 3. Again, now I have a variable, but the rule is going to stay the same. 3x plus 7x gives me 10x, and then 7x minus 3x gives me 4x. So I know that the third side has to be greater than 4x, but less than 10x in order to have segment measurements that will form a triangle.